Hello everyone. Yeah, I've got my sensor, uh, and I bought it with a cover as well. But quite frankly, the cover's shit. I think it's just a badly made one. I don't think it's a proper one. So let me just. Anyway, this is what it is. This is a sensor. I'm going to mount it up so it's pointing at something. So I'll just grab it there and just make sure we're focused on that point. There we go, and I'll just point it at a board. Let me just change. Let's just get a different view this time. There we go. So yeah, I'm pointing it at this board here. We'll come back to that in a minute. And but I also bought a cover for it, and I just want to make people aware of the cover. Let me just pick that up. Let's just see if I can get it to focus on there. Yeah, yeah, that's what it looks like. But at first glance it looks alright, but let's put it under the microscope, shall we? So I'll just bring up my microscope, and can you see all them lines and marks in it? Right, they're shrink lines. That's when the plastic inside the mould shrinks, and it creates shrink lines. And there's also injection marks. These are when the plastic cools before it actually gets fully injected into the mould, so you end up with like wrinkles, like these long lines here. And then these little lines here is also that the plastic is not fully molten, it's actually cooled a little bit while it's getting injected, and what it does, it shrinks and you get these little ripple effects. So basically this bit of plastic mould is it's shit actually. That's the best word for it. It's a piece of crap. Yeah, I tried the cap, the cover, and basically it makes it totally useless. And anyways, so yeah, just a bit more information on this sensor. It's I2C, and if you if you're used to using Arduino IDE and devices with I2C, you're not going to do too well with the Arduino Nano or Uno or what have you, because you need some microcontroller that's quick and has quite a bit of memory. Basically, this sensor, let's just make sure I'm focused there. The sensor, it has its own microcontroller on it, and that microcontroller on this little tiny chip needs a it's the VL53L5CX, by the way, and it needs firmware uploading to it every time you power it up, because basically the memory that's on it is volatile. So every time you turn this off to stop power to it, it loses its firmware to actually run. So when you power it up for the first time and initialize it, you have to upload its firmware, and its firmware is about, well, it's 21956 bytes, so it's nearly it's pretty much 2 kilobytes. Sorry, it's 22 kilobytes of firmware you have to upload to it first. And so whatever microcontroller you have connected to it has to be able to upload that amount of memory to it. And for this, actually, I'm using the well, what is it? I'm using this little chip here. It's it's called the black pill, which is the STM32F401RCT6. So I'm using that microcontroller because it's quick and it's got a fair bit of memory on it, and we can upload the firmware to it, and then we can start using it. So all we need to do for this is we need to, well, I've got it connected up here. This is the cable. What the hell is, oh yeah, it's my power. Right. We've got this connected up to the I2C on this microcontroller. This one here is connected up to a USB to UART connector, so we connected here to the UART on the microcontroller, and this goes off to the UART to USB device. Hang on, I'll just get one and show you what it's connected to. Here we go, that's what one of them looks like. It's the USB, it's got the CH something or other chip on it. You probably need to install drivers for that, but then this connects up to these two wires down here on the UART, and that plugs into the PC. This is so I can get data. So basically this STM32 is, first it uploads the firmware, and then it starts reading data from it back to it, and then what it does, it sends that data up through the UART to the converter that goes into my computer into a USB. This other lead is for programming the chip, and this goes to the ST link so that we can program it. Okie doke. Okay, so let's get to the good bit. So to enable to see what this sensor is actually seeing, because at the moment it's just pointing towards this flat piece of hardboard, I decided to make an application so that the STM32 can send the information to my application, and my application will show a visualization of the sensor. So let's just start that up. Takes a bit of a while just to set itself up, and there we are. I've put this on Microsoft Store so it can be downloaded. You just need to ask me for the firmware, and you can upload the firmware for the ESP, the STM32 black pill. If you get one of those, you get a USB to serial device and ST link. Download ST's program firmware programmer, and I'll give you the hex file to go onto this. You plug it all together, and then you just run this, and we connect. So we click connect, and you can see there that I've got this set at 300. Basically what I've got, where's my ruler? Yeah, I'm working in this sort of range here, so this goes up to the board, and I'm currently running at that, well, it's about 260 away. Is that what it is? No, it says 300. Anyways, maybe some calibration needed. But anyways, let's just go, well, let's go try 350. Is that better? There. It's hitting something now. But basically what I've done is with this grid here is I've whatever the work area, so I mean we can go up to 4 meters. Let's go up to 4 meters, but you can see that the now the length is pretty short there. Let's just see if we can get that closer. Yeah. There we go. You can see it's very close to, you know, so 4 meters is what I've done is see this box, the floor, that will be the floor down here. I've made that a certain size, and everything 4 meters is scaled down into this box basically, so you can see that we've only got a little tiny bit. But if we just make the work area say 350 or 343, whatever, let's just type that in there, 350. Okay, you can see that everything's now scaled up to this. My working area is scaled up to the box now. Okay, you can see that. So I'm working in with this area, and we can see me ruler getting moved in. So where shall I put this? I'll put it here. Right. So these colours, they're sort of like all the colours of the rainbow, and it's scaled between 350 and 0. So depending how close things are to it, it will change colour in relation. Further away we're into the red spectrum. Let's bring that down to 300 again, like that. So further away we're into the max reach there, it's in the red spectrum, and then closer to it, if we bring something right up, we're into the blue, and everything in between gets all the other different colours. Yeah, so let's just get my finger to point in, and you can see that my little finger is coming in there. And we can see that I am pointing, and it gives you a good visual. If I move closer, it's going to fill the thing up there, and move further away, it's going to go into the red. Let's see if I can get a better view. Like I say, I'm quite pleased with this application. It's the first time I've done sort of like 3D real-time sort of programming. I'm getting quite. It's better than my last attempts, anyways. So yeah. So we've got the real time here. Let me get something round. Yeah, get a bit of round disc. So what I'm doing is that I'm just holding this disc in my tweezers. So hopefully we just get the circle. And what I'm going to do is I'm going to stick that. So back here, let's see if we can get that in the middle. I move it closer. Obviously, the closer it is, oh, there we go, and we can see it picking it up there. And I move it further away. I think that's my hand there. So yeah, I could play with this all day. Like, and we can resize this. So let me just put that up there and drag it down. I get a better view this time. Like I say, increase the size. Let's just I still want you to see what I'm looking at there. There you go. Yeah, and I've made the colours of these dots the same colours as these as well. And like I say, these numbers, these are all in millimeters. So I mean, that's a flat disc, so all these are supposed to be the same. But anyways, so yeah, so get right close, block it completely, and then get further away, and yeah. Like I say, I can play with this all day. You can make it as big as you want as well. You can make it full screen. Let's see if we can move that across a bit there. You can just move it around. So yeah, I hope you like this, guys. So I'm thinking now that my scanner's got a big chance now, and if I've got this on the end of my arm, I can scan 16 point clouds at once, and hopefully it'll work. Don't know yet. Like I say, I've still got to work out how to get it's all programmed onto the same chip and merged at the same time. But you know, I'm just messing about, guys. It's just a project, and I'm having fun doing it and learning stuff. So yeah, I've really come a bit further forward now with my programming skills, especially to make this. So hope you enjoyed it, and hope it was of some interest. Catch you on the next one, guys.